Okay, so let's see what you guys remember from the video. The video talked about functions and then what an inverse concept was. So let's just take a look at an example of a basic function like f of x is equal to 2x. Now, it was often helpful to take a look at the function as inputs and outputs. So if I took a look at the input number 2, what would be the output value? 4. Okay, so 2 would get mapped to 4. And if I looked at, I don't know, 3, what would 3 get mapped to? 6, yeah. Let's keep it easy. How about 4? Map to 8, yes, excellent. Now let's see if you remember what they talked about as far as the inverse concept. The inverse function, and it looks like this, f negative 1 of x. What does the inverse do? Does anybody remember from the video? It goes backwards. So it takes the range value, for example, of 4, and it would plug it in and say the answer would come out to be 2. So the same thing with 6. You would take the 6, bring it out to be 3, and you would take the 8 and bring it back out to come out to be 4. So inverse is like another name for opposite. In fact, whenever I see the word inverse in math, I just think opposite. Just helps me think of kind of what the inverse does. In fact, when you guys were learning like basic equations, your teacher might have even said, hey, if we have 2 times x equals y, we need to undo multiplication. They might have said, what's the inverse operation of multiplication? I don't know if you remember that, but what's the answer? What's the inverse operation of multiplication? Division. You're undoing what's been done. So if you think about it in terms of an inverse function, you're taking the range value and you're undoing and bringing back to the x coordinate. Let's take a quick reminder of how do we find an inverse function. So if I have f of x is equal to 2x, we can think of that, so I'm going to do a little thought bubble. We can think of that as y is equal to 2x. And how would we find the inverse? The inverse based off of what the video stated. Keenan? Yep, we have to... Did they say, so the inverse I think just said solve for x, right?
Yes.
Yeah, find the x. Another way to do it is if you wanted to, you could just switch y with the x and switch x with the y and then solve for y. So this is kind of a precursor step. So what undoes multiplication? Division, we would divide by 2. And we would have y is equal to x divided by 2. And instead of calling it y, this is the inverse function. So we'd say the inverse function is equal to x divided by 2. Now I know the video always says just solve for x, and then that's your inverse function. I actually just right off the bat replace the x and the y, and then solve for y, because I'm so used to in my math career just solving for y. So that's actually what you'll see me do as I find inverse functions. But then let's see if this works. Is this the inverse function? If I plug in the number 4 into that, do I get an answer out of 2? And if I plug in 6, do I get an answer out of 3? And if I plug in 8, do I get an answer out of 4? Yeah. Now you can always, that would be bad if it was no. You can always find the inverse using those steps. We'll do it again at the end of the notes. But the inverse is not always a function. So how do we determine if an inverse is a function? Well, first of all, let's recall what it means to actually be a function. So you'll see this wording down here at the bottom. I want to make sure that this is getting recorded. I don't know what I'm doing. Let's just do it that way. Okay, recall what it means for a relation to be a function. Do you guys remember what we would put in these blanks? If it's a function, and actually I'll do it in blue because that's what my function was. Nope, I think I'll do it in blue. Then every element in the blank is mapped to exactly one element in the, do you guys remember what goes in these blanks? Every element in the domain, good. Why does it do that? That's weird. Okay. In the domain is mapped to exactly one element in the range. Remember how I think of it? I think of no one man can have 2 masters. So basically if you see 2 arrows coming from one x value, that means no, it's not a function. Or on a graph, we would look up the vertical line test, and we would want to make sure the vertical line doesn't hit the graph twice, because if it does, that means that you have 2 different x's to 1 y. That's what it means to be a function. How can we tell if a function will have an inverse that is also a function? The answer is if a function is called one-to-one. So go ahead and write it verbally with me. It says 1, 2, 1. Now, what does it mean for a function to be one-to-one? If you got the paper copy when you walked in, I'm sorry. I think that the copier, for whatever reason, didn't copy these words. So I'll give you some time to write it in. But a one-to-one means that a function for which, or is a function for which every element of the range of the function corresponds to exactly one element of the domain. Exactly one element of the domain. Now that's a lot of big words, so we're going to see what it means, but I'm going to give you guys a chance to copy it first. Can you not make this bigger? I don't think you can. Okay, maybe I can do that. So again, you're going to hear this terminology as we start working with inverses, this one-to-one. What it means is if a function is one-to-one, then it will also have an inverse function. So let's take a look at what it would mean to be one-to-one. So tell if the following are one-to-one, and I'm going to have you write in these numbers. So first of all, I'm going to wait till everyone's done writing down that definition. Okay, go ahead and write in the numbers like 3, 6, 7, and 8, and 9. Three, 6, 7, 8, 9. I want you to map 3 to 8, and 6 to 8, and 7 to 9. Now, my first question for you is, would this be a function? Is it a function? I'm not asking for one-to-one, but is it a function? Yes. It's a function, yes, because every x value has a unique value in the range. If I graphed those points, 3, 8, and 6, 8, it would pass the vertical line test. Now my question is it one-to-one? Let's look at the definition. It's a function for which every element of the range, so that would be the second part. Remember, this is your range, this is your domain. So every element of the range of the function corresponds to exactly one element of the domain. So yeah, you guys see the problem, right? The problem is right here. If it's one-to-one, it's going to have no double arrows with one number. So this is a function, yes, but it is one-to-one, no. No, because 8 is sharing 2 x values. Okay, then if I give you a different example, one off to the side here, like the number, I'll make this up, 4, 5, 6, 7, 8, 9. Oh, cool. Can you just put them on that shelf above the, yeah, just anywhere you can fit them. Perfect. Thank you. Okay, so if we have something like this, 4 being mapped to 7, 5 being mapped to 8, 6 being mapped to 9. Turn with your partner and discuss if that is a function and if it's one-to-one. Yes. Okay, good. I heard it. Yes, it's a function. Check. It's one-to-one. What does that mean? That means that this function has an inverse that is also a function. So the inverse would also pass the vertical line test. Now, graphically, let's just review. Graphically, we can take a look very quickly at a function and see, is it one-to-one? First of all, think about the old information. The vertical line test was used to determine if a graph is a what? Is a function. This new information, the horizontal line test, determines if a function is one-to-one. So if you want to write out those words 1-2-1, that's fine. It's the same exact thing. It's just either written out sometimes or sometimes it's just given with the 1:1. Okay, so let's take a look at examples and see, well, how do we know if a function, or what does the graph look like if it's one-to-one? So this is also a review for tomorrow's test because we have to think about, well, how do you graph something like this? So square root of x plus 5, you want to think about what your square root graph looks like. What is the x plus 5? How is that going to shift from the origin? It's going to move to the left 5, good. And then what's this negative going to do to it? Is it going to reflect it over the x-axis or over the y-axis? Over the x. I always just think upside down. But yeah, that's technical. Over the x-axis. So if we think about reviewing from yesterday, or not from yesterday, from last chapter, if I would graph a basic, and you don't have to graph this, but just so you think about your points, a basic square root graph, y equals square root of x, would have the points like 0, 0, 1, 1, 4, 2, and it would look like this. This graph that's being changed has to go to the left 5 units and reflect. Now, sometimes it's more helpful to think about reflecting the function first, just so you don't end up in the wrong spot, and then you move it 5 to the left. So we go 1, 2, 3, 4, 5. And instead of having 1, 1, I'm now going to have the point 6 or negative 6, positive 1. And there is my function kind of off to the left there. Okay, so here's my function. Now I have to ask, is this one-to-one? So you're asking, does it pass a vertical line test and a horizontal line test? Is it a function that is also, that would have an inverse? So first of all, is this a function? Did I do something wrong? Ah, this is on tape. Ah, silliness. All right, sorry. I should have reflected first. Well, we all make mistakes, right? Thank you so much. My son, my 4-year-old tells me that. He's like, Mommy, we all make mistakes. Sometimes we just don't get it right. And I'm like, you're right, buddy. Okay, so I'm sorry. That was my mistake moment. What did I do wrong, guys? You gotta reflect it upside down. I even said that and then I didn't do it. So if I reflect it upside down and then move it to the left 5, I have negative 1, 2, 3, 4, negative 5. There it is. Thank you, guys. Everybody makes mistakes. Everybody has those days. Yes. Yes. Thank you, Jeremiah. I needed that. All right, guys. So first of all, is this a function? Yes, it passes the vertical line test. Is it one-to-one? If I draw a horizontal line, it only crosses the graph once. So yes, this would be an example of a one-to-one. Meaning that when I find the inverse, that inverse will also be a function. Okay, let's think about example 2. Actually, example 2, why don't you try this one with your partner? First, describe the shifts as if you would have to do on the test tomorrow, and then just determine, is it one-to-one? Okay, so go ahead and take a few moments and do that.
And it's just example 2.
Yeah, just example 2. All right, guys, what did you think? Is this one-to-one?
No.
No. Why is the answer not? Why is it not one-to-one?
Because it doesn't pass the horizontal.
It doesn't pass the horizontal line test. Basically, when I take this function and I reflect it over the line x equals y or y equals x, I know they said that in the video, when I graph the inverse function, it won't pass the vertical line test. So it's not a function, or the inverse will not be a function. So we just say for right now, no, not one-to-one. Okay, let's take a look at example 3. Oh, I love example 3. This is definitely going to be a test question tomorrow. So y equals, parentheses, the opposite of x plus 3 cubed. And the test question's not going to say 1 to 1. It just means how will this graph be reflected, or how would it be formed? So, okay, can someone raise their hand and tell me what will happen with this quantity negative x plus 3? Is that a left shift or a right shift?
Right.
Good. Catherine, why did you say right? Good. When you're looking at your left or right shift, you need to look at it in the quantity with a positive x value. Let me say that again. When you're looking at your left or right shift, you need to look at it in the quantity with a positive x value. So this x minus 3 actually tells me that this graph will be moved right 3. How will it be reflected, over the x or over the y? Over the y. This one's the different one. So if I think about graphing this, if you wanted to remember the original function, original cubic would go like this. You'd have points on it like 1, 1 and negative 1, negative 1. So if I reflect this over the y-axis, it's now going to reflect here, but then I need to move it right 3 units. So now I'm going to have the new point of 3, 0, and then I can go up 1, right 1, down 1, and graph this new shape. Now let's say that I forgot my shifts, and I'm like, oh my goodness, I don't remember which way's left, which way's right. What could I always do? Maybe even what could I do on tomorrow's test? Plug in points and see, hey, where does this graph end up? And keep plugging in points until you know where it is and how it looks on the XY coordinate plane. The transformation, the shifts, are just meant to make your work faster. But if you're like, I forgot, just do a table. Okay, now if we draw a horizontal line, is this 1 to 1? Yes. So this would be yes, 1 to 1, meaning when I find the inverse, it will be a function. Okay, let's go ahead and let's take a look at the second page. Yeah. Yeah, Catherine. Reflect first and then shift. Reflect first and then shift. Good question. Okay, so here's a function. F of x is equal to 2x plus 4. The inverse would be defined as 1/2 x minus 2. Does this look familiar at all? It's the exact one that was in the video. Just took it just to kind of reinforce this. But yeah, it's the exact one that was in the video. So if we think about, and this is just reinforcing the concept of an inverse. So it's basically the same as we did above. But if you use those numbers again, like 2, 3, 4, 2, 3, 4. If you plug in 2, what would you get as an output answer? 8. If you plug in 3, you get an output of 10. If you plug in 4, you get an output of 12. So just reinforcing from the video, 2 is mapped to 8, 3 is mapped to 10, 4 is mapped to 12. The inverse, again, it brings back the x value. So if I start with 8, 10, and 12, if I just was thinking about what the video said, what should 8 be mapped to? 2. Now I can check it because I gave you the exact inverse function. Half of 8 would give me 4. 4 minus 2 would give me 2. So yep, maps it back. 10 should be mapped to what? 3, and 12 should be mapped to 4. So what things do you notice about a function and its inverse? Anybody notice anything? You could look at it like, sorry, I didn't hear you, Linda. Did you say that it just flips? Yeah, the domain and range just flips. That's true of all inverses. The domain and range flip. Okay, with your partner, go ahead and fill out the function and its inverse for 6, 5, negative 2, 16, 4, and 0. And then we'll talk about that last step. So use the same functions at the top of the screen. And then, sorry, yeah, that's confusing. Use the same ones at the top of the screen. And then go ahead and plug that in.
6, 12 plus 4. Oh, you know. I feel really uncomfortable now.
Lauren, I love that you did it so fast. Good job. All right, you guys, some of you did this really quickly because you noticed after you started doing the first few that the inverse, it just brought back the original x value. So for example, if we found f of, oh, that's not a highlighter, that erases that. If we found f at x, the inverse is going to bring back the x value. The f of 5, the inverse will bring back the 5 value. F at -2, the inverse will bring back the -2 value. So let's just kind of extend this to a variable then. F of x will equal, well, whatever your function comes out to be, so the output. So if you take this output and plug it into the inverse, yes, exactly right, Jeremiah. You're going to get back your input. So what will our answer to the inverse of a function equal? Just x, whatever you plugged in for x. And I should have done that in like a different color. Okay, so for the function and its inverse, evaluate the following. What would it be at f of 2? Well, if we plug that in to these functions here, I'm plugging into function f. So I would have f of 2 is equal to 7 times 2 minus 2, which would give me 12. And what should the inverse, if that truly is the inverse function, what should it bring back? 2. Now, could you check it? Could you plug in 12 into the actual inverse? Yeah, 12 plus 2 divided by 7 does come out to equal 2. So, keeping that in mind, we actually don't have to, if you're grasping this concept, you actually don't have to plug things in. What would be the function f of its inverse at the input value of 12? What would it come out to be, Maggie? 12, exactly right. What would be the inverse of the function at 2? 2. Now, if you didn't believe me, you could just plug the inverse function 12, take that answer, take it and plug it into the outside function f, and you're going to find the same thing come out. An inverse, it's like opposite day. It just undoes whatever was done to x and brings it back to its original form. Now, quick reminder from the video, how do we find its inverse? I know I reviewed this at the top of the notes, but let's really drive this home. So given this new function, f of x equals 2x squared plus 4, find its inverse and then graph them both. Is the inverse a function? So let's go ahead and let's find the inverse. So if you consider this instead as y is equal to 2x squared plus 4, the video said solve for x, and that's your new inverse. I kind of flip that and I just say switch x and y. But if you understood the video way and you want to stick with it, totally fine with it. But I say switch the x and y, because what you're doing is you're switching the domain and the range, and then solve for y. So I'm going to switch that out here, make this, oh, that's weird, everything went to the other side. So I'll switch this to x, switch this to y. And that's simply just because I'm used to solving for y. So I like doing that. So after you switch x and y, you're going to solve for y. So we'd subtract 4, giving me x minus 4 is equal to 2y squared. What would be my next step if I'm solving for y? Divide by 2 to everything. So I'd have y squared is equal to 1/2 x minus 2. Or you could call that 1 over 2x, but. And then finally, what do I have to do to solve for y? Take the square root, and what do I need to keep in mind when I take the square root? Plus or minus answer. So I have plus or minus square root of 1/2 x minus 2. Now instead of calling that y, we know that this is the inverse, so we can just replace that with the notation the inverse of x comes out to be this equation. Is it a function? I'm not sure yet. Now, bringing it back from the beginning of the notes, how can you tell if a function will have an inverse function? You see if it's 1 to 1. So going back to what we know about this equation, if I'm graphing the function, go ahead and just create a little xy axis. What will the plus 4 do to the function? Move it up 4. What does the 2 do? Makes it 2 times narrower. So if I think of an original x squared that goes through 1, 1 and negative 1, 1, 2 times narrower means that it's going to take this y value and bring it up by 2 after we move it up 4. So I'm going to go ahead and I'm going to move it up 4. So 1, 2, 3, 4, the new vertex value is at 0, 0. And instead of going up 1 and right 1, instead of having that point of 1, 1, it's now going to be stretched up by a factor of 2. So here's the original function. This is my f of x. Now, quick question for you. Is this 1 to 1? No, it's not. So that means when I find the inverse, it's not going to pass the vertical line test. Now let's think about if you guys can remember from the video. From the video, do you remember how you can quickly graph an inverse? Do you remember what they said? It's reflected over the line y equals x. So if I think about drawing the line y equals x, that's just when x is 1, y is 1. When x is 2, y is 2. Here's your line y equals x. You can reflect it over. Now the way that I think about it is every original ordered pair, you just flip. So if I think about the function f of x, I'm going to create a table. I'm a table person. I like seeing the actual numbers. So if I think about xy, well, we have the point 0, 4. We have the point 1, 6. We have the point negative 1, 6. Now the inverse switches the domain and the range. It's opposite day. So the inverse, not only will it be reflected around the line y equals x, but basically every xy value that was in my original function just gets flip-flopped. So instead of having 0, 4, it's flipped to 4, 0. Instead of having 1, 6, it's flipped to 6, 1. And instead of having negative 1, 6, it's flipped to 6, negative 1. So if I graph these points, 1, 2, 3, 4, there's 4, 0. Graph 6, 1, so 6, 1, and 6, negative 1. Here's my inverse. Now you guys can visually see it. The original function was not 1 to 1. Not 1 to 1. That means that it doesn't have an inverse function. It still has an inverse, just the inverse is not a function. And you can see it visually now here because you can see that doesn't pass the vertical line test. That's not a function. Any questions on that?